So fourth video on Chapter 8 review. Let's see. So we'll graph this. So find the coordinates of H and show how you know. Okay. Oops, that's M. So what we're looking at here is, if it's a rectangle, it's got to be a parallelogram. So we'll just use that. The slope of A to T is going to be a right 1, 2, 3, 4 down 2. So from M, if I do the same thing, right 4 down 2, we're going to land on the only possible spot for H. If it really is a rectangle, H has to land at 1, 1. Okay. So, let's see. Show how you know it's a rectangle. It depends on how many points this is. Let's say it's a full-on 6-pointer. I would have to get the slope of every side, okay, which is what I'm going to do. And instead of the formula, I'm just going to count the squares and use those. So that's 2 and 4. Just be pretty careful here. If you're not accurate, you can get these points off by 1. All right, so you should get numbers 3 and 6 for AM and TH. AT and MH should have the 2 and the 4. So we're going to talk about slopes first. This is going to be our evidence. Okay, so we're going to talk about AM. The slope of that is up 6 over 3, and it's positive. So that's going to reduce down to 2 over 1. Let's see, AT. We're going to use a negative 2 over 4. So it's the change in x, or the run is 4. It's in the bottom. Rise is 2, and that is going down as we move left to right. Okay, that's going to be negative 1/2 when you reduce it. TH, same numbers as AM, 6/3, 2 over 1. And HM, looks like same numbers as AT. Yeah, negative 2/4, so negative 1/2. Okay, show how you know it's a rectangle. I'll do the full proof. I don't think we need to, but I'm going to say AM perpendicular to AT, AT perpendicular to TH, TH perpendicular to HM, and HM is perpendicular to AM, because their slopes are negative reciprocals. Now, really be careful about this. Gotta say slopes, gotta say negative reciprocals. Don't say opposite reciprocals. We can't accept that. Have to say negative. Okay. Now, angle M, angle A, angle T, and angle H are right angles, because perpendicular segments. Form right angles. Okay, and then lastly, math is a rectangle because it has 4 right angles. So I'm just prepared in case that, in fact, it is a full-on proof, 6 points. That would be worth at least 4 there. Now, which transformations will map the rectangle on to itself? Reflect on a line is definitely going to happen. There's 2 lines of reflection, 2 lines of symmetry. So mapping onto itself is symmetry. Rectangles have 2 lines of symmetry. So if we have a situation with a rectangle, okay, that's what it's going to look like. Good enough. I mean, we didn't, it just said which. It didn't say be specific or tell which the lines are. So I'm not going to get into that. Okay, that's good enough. Rotational symmetry, yes. Okay. Okay, rotational symmetry. That's going to happen here, where the diagonals cross is going to be the center and 180. All right, center at a point where diagonals cross. We'll use the geometry term intersect, and angle is 180. All right. Translation, no, because every point moves the same amount, so we're going to be off. There's no way to map onto itself. And dilation's kind of a trick. You know, technically you could dilate with a scale factor of -1 if the center is at the center, same center of the rotational symmetry, but I don't think they mean for that. So I'm just going to throw it out, and I'm not going to get into dilations of scale factor of 1 or -1. So we're going to throw that out. You know, you could probably mark me wrong for that, but they don't want that is the intent of the question. Okay. 28. All right, 1, 2, 10, 5, 9, 8, and 0, 5. Okay, show that it's a rectangle. We're going to do pretty much the same thing we did over there. We're just going to calculate the slopes. So M, A, P, H. All right, we're going to get the slope of every side. That's 1 by 3. Let's just double check that. Yep, it's 1 by 3. I'm just checking the numbers here. That's 1 apart, and then those are 3 apart. So 2, 3, yeah, that's 9. 3 and 1, 3 and 9. Okay, so slopes of every side. Let's just start with HT. M is 3/9, so reduce to 1/3. TA is -3/1. No reducing, right? The rise is 3, the run is 1, and it's going down. All right, AM, 3/9 again, reduces to 1/3, and M to H. Yeah, that's 3/1 with a negative, though. Okay, so show that it's a rectangle. This is our evidence that we're going to use. Now we're going to draw our conclusion. And then we'll summarize. So the conclusion comes from, there's 2 steps to the conclusion. Okay, first all the perpendicular lines. Technically, I should do this. TA perpendicular to AM, AM perpendicular to MH, and MH perpendicular to HT. Why? That is because their slopes are negative reciprocals. All right, let's see. Okay, now there's really 2 conclusions. I'm going to say angle M, angle A, angle T, and angle H are all right angles. Because perpendicular segments form right angles. Now your teacher might let you, um, if they do, it's fine. They might let you skip right from the slopes are negative reciprocal to right angle. I would take it, but you kind of should go through perpendicular first. But it's a minor detail, and I'm not going to take off for it if I see it. But hopefully you remember to do it perpendicular, then right angles would be better. Okay, now summary. Okay, math is a rectangle because it has 4 right angles. All right, that'll be it for this video, and hopefully we can finish on the next.